Hello students. In this video we are going to study Introduction to Three-Dimensional Geometry from class 11. Believe me, it's quite an easy topic provided you understand all the examples. So watch the video till the end and subscribe to the channel. Coordinates of a point in space. Like we have the coordinates of a point with respect to x and y axis, in 3 dimensions, the coordinate axes of a rectangular Cartesian coordinate system are 3 mutually perpendicular lines. Means instead of 2 axes, there will be 3 axes which will be mutually perpendicular to each other. They are the x, y and z axis. The 3 planes determined by the pair of axes, the coordinate planes, they are called the xy plane, the yz plane and zx plane. So 3 planes will be generated, xy, yz and zx plane. The 3 coordinate planes divide the space into 8 parts and it is known as octants. The coordinates of a point P in 3-dimensional geometry is always written in the form of a triplet. Means it will have 3 coordinates x, y and z. Here x, y and z are the distances from the yz axis, zx axis and xy planes respectively. That means x is the distance from the yz plane, y is the distance from the zx plane and z is the distance from the xy plane. Now remember these points. Any point on the x-axis will be of the form x 0 0, y-axis it will be of the form 0 y 0 and z-axis will be of the form 0 0 z. Let us understand the octants. The sign of the coordinates of a point determine the octant in which the point lies. And this is the table for it. Now if you see the diagram, in the first octant x, y and z, all the 3 coordinates will be positive. Correct? You can see in the diagram. In the second octant, x will be negative but y, z will be positive. So you can just see the second octant, in that only x is negative, y and z coordinates are positive. When you move to the third octant, you will be having x and y negative but z is positive. You can see that z is positive in the third octant. Similarly, you have the 8 octants. Now you can be asked objective examples based on this. An easy way to remember this table is you have the x, y, z coordinates and you have the 8 octants. First, suppose if we consider z, in the first 4 octants it is positive, in the last 4 it is negative. Then we come to y, first to positive, then to negative, again to positive and then to negative. And for x coordinate, positive, negative, negative, positive, positive, negative, again negative, positive. So you need to remember this table. Now the distance formula between 2 points in 3D geometry. Suppose you are having 2 points P with coordinates x1, y1, z1 and Q with x2, y2, z2. Then distance between PQ is given by PQ is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is a similar formula like you had in 2-dimensional geometry, but here you have 3 coordinates for each point. Now remember these points, it will be really useful in solving the examples. Now suppose we want to use the distance formula and you want to prove that the given vertices, first case, you want to prove that the vertices are of a parallelogram. Then how will you prove it? Just prove that opposite sides are equal. Find out the length of the 2 opposite sides, 2 pairs of opposite sides, and if they are equal, it is a parallelogram. To show it is an isosceles triangle, just show that 2 sides of the triangle are equal. If you want to show it is a right angle triangle, just prove the Pythagoras theorem. That means the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. If you want to prove 3 points A, B, C are collinear, just prove AB plus BC is equal to AC. A given point is equidistant from other 2 points. If you want to show a given point is equidistant from other 2 points, just show that its distance from both the points is same. Suppose you want to find the coordinates of the centroid of a triangle whose vertices are x1, y1, z1, x2, y2, z2 and x3, y3, z3. Then the simple formula like you had in 2D, here also you have in 3D. It is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3 and z1 plus z2 plus z3 by 3. So the distance formula is quite simple but we need to know how to use it in the examples. First example, Find the distance between the given pair of points 2, -1, 3 and -2, 1, 3. Simply you have 2 points, use the distance formula and find the distance between them. That means it is x2 minus x1 means -2 minus 2 whole square, 1 minus -1 whole square plus 3 minus 3 whole square. And the required distance is 2√5 units. Next example. Verify that -1, 2, 1, 1 minus 2, 5, 4 minus 7, 8 and 2 minus 3, 4 are the vertices of a parallelogram. Now just as we saw in the previous slide that if you want to prove that the vertices are that of a parallelogram, just show that opposite sides are equal in length. That means here we need to show AB is equal to CD and AD is equal to BC. A has coordinates -1, 2, 1, B 1, -2, 5, C 4, -7, 8 and D 2, -3, 4 in that order. So now just we are using the distance formula and finding the distances. For example, AB, distance between A and B is root of 1 minus -1 whole square minus 2 whole square plus 5 minus 1 whole square, which gives you 6. Similarly, find the other distances. You will get AB is equal to CD and AD is equal to BC. Hence, as opposite sides are equal, the vertices are that of a parallelogram. Example 3. Find the equation of the set of points P, the sum of whose distances from A 4, 0, 0 and B -4, 0, 0 is equal to 10. Suppose our required point P has coordinates x, y and z. What is the condition which is given? AP plus BP, sum of the distances, is equal to 10. So just we need to find by the distance formula AP and BP. Now we have found AP and BP. What will be AP? A has 4, 0, 0 and P has x, y, z. That means x minus 4 whole square plus y minus 0 whole square plus z minus 0 whole square, root of that. It is given AP plus BP is equal to 10. So we can write AP as 10 minus BP. Now just square both the sides. So AP square is equal to 10 minus BP whole square means 100 minus 20 BP plus BP square. Put the values of AP square, 100 minus 20 BP, put the value of BP square. So now x square, y square, z square will get cancelled out. So what will remain? 16 will get cancelled out. So ultimately it is 20 BP is equal to 100 plus 16x. So 20 BP is equal to 100 plus 16x. Taking out 5 common, you get 5 BP is equal to 25 plus 4x. Now square this term. So you will be getting 25 BP square is equal to 25 plus 4x whole square. Means 625 plus 200x plus 16x square. Put the value of BP square. Simplify the equation. What do you get? 9x square plus 25y square plus 25z square minus 225 equal to 0. So the required equation is 9x square plus 25y square plus 25z square minus 225 equal to 0. Example 4. All the equations are of different kinds, so understand them properly. Given that P 3, 2, minus 4, Q having coordinates 5, 4, minus 6 and R 9, 8, minus 10 are collinear. Find the ratio in which Q divides R. First of all, we'll recall some concepts previously done. Suppose in general, if I have a point Q which divides PR in say ratio M is to N, then by the section formula which we have already studied, what will be the coordinates of Q? It is similar like two-dimensional geometry, but only difference is over here you will have 3 coordinates. It will be mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n, and z coordinate will be mz2 plus nz1 upon m plus n. Now we are given the coordinates of Q. So we are given what is the value of each of these coordinates. Just put the remaining values. So what is 5? X coordinate is 5 means mx2. What is x2? 9. So 9m. What is x1? 3 plus 3n upon m plus n is equal to 5. Similarly 8m plus 2n upon m plus n is equal to 4 and minus 10m minus 4n upon m plus n is equal to minus 6. Now remember, you can use any of the equations and try to get the ratio m by n. So suppose if we use the first equation, it is 9m plus 3n is equal to 5m plus 5n. So simplifying that, we get m upon n is equal to 1 by 2. That means the required ratio in which Q divides PR is 1:2. Next example. 3 vertices of a parallelogram ABCD are given, which are A 3 minus 1 2, B 1 2 minus 4 and C minus 1 1 2. You have to find the coordinates of the fourth vertex. Now, you know some properties of parallelogram. We know that the diagonals of ABCD which intersect at, say, suppose P, then the diagonals of a parallelogram bisect each other. So we are going to use this. Diagonals of a parallelogram bisect each other, meaning P will be the midpoint of AC and P will also be the midpoint of diagonal BD. What is the formula for midpoint? Like you have in 2D, but here you have it in 3 coordinates. So midpoint of AC, you have coordinates of A 3 minus 1 2, you have coordinates of C minus 1 1 2. Midpoint will be x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2. Putting the values, you get midpoint of AC as 1 0 2. And this will be also midpoint of BD. 1 0 2 will be the midpoint of BD. Now suppose the coordinates of D are x, y, z. We have the coordinates of B as 1 2 minus 4. We also have 1 0 2. So 1 0 2 is equal to x plus 1 by 2, y plus 2 by 2 and z plus minus 4 by 2. So now simplifying this, we get x equal to 1, y equal to minus 2 and z equal to 8. So the coordinate of the fourth vertex D are 1, minus 2, 8. Next example. A point R with x coordinate 4 lies on the line segment joining the points P 2 minus 3 4 and Q 8 0 10. Find the coordinates of R. You have to find the coordinates of a point R whose x coordinate 4 is given, but y and z are not known. Suppose the coordinates of R are 4, y, z. It divides PQ in, say, some ratio k:1. Correct? Now, by the section formula, what will be the coordinates of R? Remember, here we are using the section formula in terms of k. So, it will be similar like 2 dimension but 3 coordinates. So, kx2 plus x1 upon k plus 1, ky2 plus y1 upon k plus 1 and kz2 plus z1 upon k plus 1. So now 4 is equal to, what is the value of x2? It is 8. x1 is 2. So it is 8k plus 2 upon k plus 1. On simplification, you get k equal to half. Since the first coordinate, x coordinate is given, we use that to find the value of k. So we have got the value of k as half. Now put this value of k in the other coordinates. So substituting the value of k in the other 2 coordinates, what do we get? Y is equal to, what is y2? y2 is 0, y1 is minus 3. So it is 0k minus 3 upon k plus 1, but put k equal to half and simplify, you will get y equal to minus 2. Similarly for z, put k equal to half and simplify, you will get z equal to 6. So the coordinates of R are 4, minus 2, 6. Now you can be asked objective questions based on the octant table which we had seen. So now you will be just given the points, you have to write the octants. Only thing is, remember this table. For example, suppose point 4 minus 2 3 is given. First coordinate plus, then minus, then plus. So plus, minus, plus. It is in the fourth octant. Similarly, second point minus 4, 2 minus 5 means minus, plus, minus. It is in the sixth octant. Similarly, other points are given. You just have to see the sign and write the corresponding octant. Students, these are some assignment examples. Please solve them to get a clear idea of the topic. Also, the hint and the answer is given. First one, show that the points minus 2, 3, 5, 1, 2, 3 and 7, 0, minus 1 are collinear. How will you show that? PQ plus QR is equal to PR. Then the 3 points PQR are collinear. Second one, find the ratio in which the YZ plane divides the line segment joining the points minus 2, 4, 7 and 3, minus 5, 8. First thing is, since YZ plane is given, the coordinates of the point will be of the form 0, y, z. YZ planes means x coordinate will be 0. So 0, y, z. Now use this and you will be getting the, you will be using the section formula. So you will be getting the ratio as 2:3. Third one, find the coordinates of the points which trisect the line segment joining the points P4, 2, -6, Q, 10, -16, 6. What is the hint? If suppose you have 2 points A and B, trisect the line segment joining the points PQ. Trisect means it divides into 3 equal parts. So what will be the ratio? For the first point, the ratio will be 1:2, and for the second point, 2:1. So the coordinates which you will obtain is 6, -4, -2, 8, -10, 2. This is like the section formula which we had studied for 2 dimension, but only difference is here you have the 3 coordinates. Fourth example, find the lengths of the medians of the triangle with vertices A 006, B 040 and C 600. Now we know how to find the medians. Medians means it divides into 2 equal parts. So we will be using that. The answer is the length of the medians will be 7, root 34 and 7. Fifth assignment example, find the coordinates of a point on the y-axis which are at a distance phi root 2 from the point P 3, -2, 5. Now first thing is it is given that point is on the y-axis. That means which type of coordinates it will have? 0, y, 0. So just use that and then find the coordinates. Distance is given. You can use the distance formula and the points will be 0, 2, 0, 0, -60. Why 2 points? Because you will be getting 2 possible values of y. So you will be getting 2 possible points. Sixth one, find the equation of the set of points which are equidistant from the points 1, 2, 3 and 3, 2, -1. We have done a similar example. The equation will be x minus 2z equal to 0. Seventh, find the coordinates of the point which divides the line segment joining the points -2, 3, 5 and 1, -4, 6 in the ratio. First thing is if the ratio 2:3 is internally, means it internally divides. Second thing is 2:3 externally divides. What is the formula? Formula for internal division, you know, mx2 plus nx1 upon m plus 1 and so on. External division, the formula is similar, only you have a minus sign. So for external division, the coordinates will be given by mx2 minus nx1 upon m minus n, my2 minus ny1 upon m minus n and mz2 minus nz1 upon m minus n. The answers are also given. So 3-dimensional geometry is comparatively a small topic with just a few formulas to remember. Do like and share the video and subscribe to the channel.